Global food security is facing a severe pressure test. Artificial intelligence is disrupting labor markets, geopolitical fractures are tangling supply chains, and droughts and severe weather are aggressively rewriting planting seasons across the globe. For millions of smallholder Indian farmers, these macro trends translate to a very harsh physical reality. They are attempting to survive modern climate volatility using hand tools and irrigation methods that are centuries old. This graphic highlights the core paradox. On the left, we see over 50,000 crore rupees in government subsidies and a drone market growing 32% yearly. Yet on the right, data shows 98% of farm households still operate without access to these modern technologies. The required technology exists. The capital to fund it is readily available. The system is breaking down at the last mile. It is a failure to physically deploy these engineering solutions into the village itself. You cannot operate aerospace hardware purely through a remote software update. High-capacity agricultural drones require heavy batteries, chemical mixing protocols, and certified maintenance. They need physical routes in the locations where they operate. As shown in this rendering, Ojas Aerospace has engineered the missing infrastructure to solve this exact bottleneck, the Meghdev Drone Station. These hubs are modular, built into self-contained units powered by solar arrays. This design allows a complete operational facility to be transported and dropped directly into remote, sub-district farmlands. Instead of keeping deep tech locked away in urban corporate research parks, this decentralized network plants aerospace engineering directly into the rural soil. Step off a dusty rural road and into one of these active hubs, and you find a highly structured ecosystem. These locations manage hardware sales, schedule drone spraying rentals, run battery maintenance, and facilitate DGCA-certified pilot training. For the first time, local farmers can walk through a door and interact directly with industrial-grade aerial spraying hardware and sophisticated touchscreen kiosks to book government schemes or check crop prices. Once you solve the last-mile logistics barrier for agriculture, you solve it for everything else. A network capable of navigating remote terrain to spray fertilizer can be utilized to deliver emergency medical supplies or conduct rapid surveillance for disaster relief. The station functions as a multi-purpose gateway. By establishing this physical beachhead, a village gains logistical capabilities like cold chain support and rapid delivery that were previously geographically impossible in remote regions. Out in the fields, this physical hardware powers the virtual farming network. Drones fly over fragmented physical land plots, capturing spectral data to generate an exact digital replica of the farm, known as a digital twin. Artificial intelligence evaluates this replica to identify nutrient deficiencies and calculate targeted spray paths. This allows farmers to replace intuition with measured evidence. This flowchart illustrates how that data creates a financial bridge. With the farmers supported by smart hardware and data pipelines, the risks of traditional agriculture are isolated and managed. An urban investor can now confidently fund a remote rural harvest from hundreds of miles away. By digitizing the soil, the virtual farming network takes an industry traditionally defined by uncertainty and structures it into a data-backed financial asset. For decades, younger generations have been abandoning their ancestral homes for crowded urban centers. Traditional farming offered heavy physical labor and razor-thin profit margins, leaving behind a palpable socioeconomic vacuum. We are now seeing a new workforce step into that vacuum. Young rural men and women are being trained as Hal Sathis and Hal Didis. They are managing high-tech flight operations and acting as digital agronomists in their own communities. Experienced IT professionals and urban entrepreneurs are packing up and returning to their home districts to launch and manage these lucrative franchise hubs. The deployment of these stations creates a localized tier of technical jobs. By offering profitable, high-tech roles within the village, the network provides a viable alternative to the traditional migration toward urban labor markets. This map visualizes the scale of the 2030 mission, expanding from a single operational center to a lattice of 100,000 stations, capable of digitally connecting 200 million farmers. Millions of families entered this decade relying on animal labor and wooden plows to simply break even at harvest. Beyond its impact on domestic food security, this model serves as a decentralized architectural blueprint for smallholder farming economies across the developing world. This infrastructure closes the loop between aerospace engineering and the individual field, repositioning the Indian farmer as a key operator in a high-tech national network.